Hello, and welcome to the third lesson of organic chemistry. This lesson, we will be looking at the process called cracking. By the end of this lesson, hopefully we will understand the process of cracking, be able to recall the structures of alkenes and alkanes, explain the process of cracking, and to be able to predict the products of cracking. So to get us started, I'd like you to have a look at the following three questions. What are the names of the first four alkanes? What are the names of the first four alkenes? And third question, what is the test for alkenes? Once crude oil has undergone fractional distillation, we have lots of different fractions of varying uses. However, there is a large proportion of long-chain alkanes. Long-chain alkanes are not very useful as they have low flammability, meaning they are not easily burnt for fuels. By breaking a long-chain alkane into smaller molecules, the alkanes are more flammable, which makes them more useful to fuel. However, when we break long-chain alkanes into smaller chain alkanes, so they have less carbons in, we also produce an alkene. Alkenes are really useful chemicals and are used to make plastics. The process of breaking down these long-chain alkanes is called cracking. Here we have an example of a long-chain alkane called pentadecane. Its chemical formula is C15H32. After undergoing the process of cracking, it breaks down into tridecane, which has a chemical formula of C13H28, and ethene, that is an alkene, as you can tell by the ending, ene, which has a chemical formula of C2H4. Now, there is no way to guarantee it will split into tridecane and ethene. It may split into dodecane, which is C12H26, and propene, which is C3H6. And there is no way to guarantee which ones we are going to get. However, there will be at least one alkane and an alkene, and that if you take the numbers of carbon atoms in the alkane and the alkene, it will add up together to be the number of carbon atoms in the original molecule, and the same for the amount of hydrogen. So here's another example. Hexadecane, C16H34, could break down into a variety of products. If it breaks down into the alkane C8H18, which is octane, the alkene produced needs to use up the rest of the carbon atoms that were in hexadecane, so it would be C8H16, octene. Or hexadecane could break down into C14H30, and the alkene produced would be C2H4. Or another option is that it could break down into C12H26, which is an alkane called dodecane, and the alkene produced in that case would be C4H8, which is butene. No matter what alkane is being broken down, if you add the number of carbon and hydrogen atoms in the products up, it should be the same amount as the original molecule. There are two types of cracking you need to know about. The first is thermal cracking, which uses temperatures of up to 700 degrees Celsius and high pressures, which is around 70 atmospheres, to break down long-chain alkanes. The second type of cracking is catalytic cracking. This uses a catalyst called zeolite, a temperature of around 500 degrees Celsius and low pressures to break down long-chain alkanes. Okay, here are your tasks for the lesson. Number 1 is to watch the video on this link and make some notes. Number 2 is to complete the worksheet on alkenes and cracking and then self-assess your answers. Task 3 is to complete the cracking worksheet and self-assess your answers. And the final task is to write out the definitions and conditions needed for thermal and catalytic cracking. Okay, at the start of this lesson, I asked you 3 questions. What are the names of the first 4 alkanes? What are the names of the first 4 alkenes? And what is the test for alkenes? Let's have a look at our answers. So the first 4 alkanes are methane, ethane, propane and butane. The names of the first 4 alkenes are ethene, propene, butene and pentene. Remember, there's no such thing as methane because the double bond needs to be between 2 carbon atoms. Last question was, what was the test for alkenes? It is adding bromine water, which will turn from orange to colourless in the presence of alkenes. So that's the end of our third lesson on organic chemistry. Now head on over to Educate to test yourself what you've learnt. Many thanks for listening.